Okay, think about this for a second. You can buy a light bulb that shines red or blue or green. So, where are the black lights? It seems like such a simple question, right? But the answer actually reveals something fundamental about the very nature of light itself. So let's break down why a true black light is a physical impossibility. A light that makes things dark? It sounds so straightforward. But as we're about to see, that one little idea, well, it actually challenges our entire understanding of what light even is. And it's a perfectly logical question, isn't it? You can walk into pretty much any store and find bulbs that emit just about any color you can possibly imagine. So it just feels like black, a color we see literally everywhere, is weirdly missing from the lineup. What's going on here? And hey, if you're wondering about this, you are definitely not alone. It's an incredibly common question, and the answer is one of those things that's, surprisingly simple, but it completely changes how you see the world. And I mean that literally. So to solve this mystery, we have to start with the absolute basics. What are light and color anyway? Because the answer isn't about some missing technology. It's hiding in plain sight, in fundamental physics. Okay, so this is the first big mental shift we have to make. That red apple you're picturing, it isn't inherently red. Red is just the name our brain gives to a very specific wavelength of light that bounces off that apple and hits our eyes. Color isn't in the object, it's in the light. So all light is really just energy, zipping around in waves. And as you can see here, our brain just interprets those waves differently based on how long they are. Short wavelengths, we see them as blue or violet. Medium ones, green. Long ones, red. But the single most important thing on this slide, the key takeaway, is that last point. To see any color at all, light has to be added to your eyes. All right, to really make this click, let's use a perfect analogy. We're going to step away from light for just a moment and talk about something else we all perceive, sound. This makes perfect sense, right? Sound is what you hear when energy waves are present, when they're hitting your eardrum. But silence? You can't broadcast silence. There's no such thing as a silent speaker. Silence is simply the absence of sound. And right there, that's the answer. Just like with sound, color is what you see when light waves are present. Black is what you see when they are absent. Black is the visual equivalent of silence. You can't shine a beam of, well, nothing. Now, I know what you're thinking. Hold on. I've definitely seen a black light. At parties, in science museums, what about those? It's a fantastic question, so let's tackle that misconception head on. I mean, they are literally sold as black lights, so it's completely understandable why this is so confusing. But what they're actually doing is a really clever bit of physics that, ironically, proves our entire point. So here's the twist. A black light isn't emitting blackness, not at all. It's emitting a very real type of light, ultraviolet or UV light. It's just a wavelength of energy that's kind of off the chart of our visible spectrum, which makes it totally invisible to our eyes. So how does it work? Well, it's pretty cool. First, the black light shoots out that invisible UV energy. Then, when that energy hits something special, like a white t-shirt, the fabric absorbs it. And then, this is the cool part, the fabric immediately re-emits that energy as a different wavelength, one that we can see. And that's the glow you see. So notice, even here, light is still being added to your eyes, not taken away. This all leads us right back to the fundamental rules of physics. Why can't we just engineer a device that does the opposite? A flashlight that projects darkness. Well, because every light source you've ever seen works by emitting photons, these tiny little packets of light energy. To project to darkness, you'd need a device that could emit antiphotons, or maybe actively suck the existing photons out of the air. A device like that, it just doesn't work within our laws of physics. You can block light or absorb it, sure, but you can't project its absence. So, when you boil it all down, it's this simple. Our brains might see black and white as opposites, but in physics, they're not. White light is the presence of all the colors of light, all mixed together. Black is the total absence of any light at all. One is presence, the other is absence. I think this quote just sums it all up perfectly. You can always add more energy to a system to create light, to create brightness. But darkness isn't something you create. It's what's already there when you take the light away. You just reveal it. And that leaves us with a final, fascinating question. We've figured out that darkness and silence aren't things you can really create. They're just the absence of light and sound. So what else do we perceive every single day that isn't really there, but is just the absence of something else? Something to think about. Thanks for joining this explainer.